All right, welcome. If you work in the cloud, you face this one fundamental challenge all the time. How do you get your private networks to talk to each other securely? The go-to answer is usually something called VPC peering. It's like a simple bridge between your networks. But here's the thing. This bridge has a hidden, really critical flaw, a rule that, if you don't get it, can bring your whole network design to a screeching halt. Today, we're going to uncover that flaw. So let's paint a picture here. Imagine your database lives in one virtual private cloud, a VPC, and your web application is in a totally different one. You keep them separate for security, which is great, but now they need to communicate. So what do? How do you connect them without sending all that private, sensitive data out over the public internet? Well, the first and most direct answer to that question is a service called VPC Peering. You can think of it as the very first, most fundamental bridge that you learn how to build when you're working in the cloud. So what is it exactly? At its heart, VPC peering is just a private one-to-one connection between two VPCs. And the cool part is it uses the massive internal AWS network backbone. That means your data never, ever has to touch the public internet. It's a direct Layer 3 routing connection. The absolute easiest way to think about it is like a virtual network cable. You're basically just plugging one VPC directly into another. And that right there shows you just how simple it is. Because it's a direct, private link, you don't need to mess with complicated network address translation or NATs, and you don't need any internet gateways for this to work. Okay, and for all you networking veterans watching, the source material gives us a perfect analogy. You can think of a VPC peering connection as being a lot like a static VRF to VRF connection from the Cisco world. It's just a simple point-to-point link between two totally separate routing domains. Let's just quickly run through the main features here. It's private and secure, for sure. It's got global reach. You can connect VPCs across different regions, even different AWS accounts. And it's point-to-point, which just means both sides have to agree and update their route tables. But hang on, look at that last one, the crucial limitation, no transitive routing. And folks, that right there, that's the big gotcha. It's the whole reason we're talking about this today. All right, so let's dive into that. This is the single most important and honestly, the most misunderstood part of VPC peering. This is the one rule that if you break it, you'll be pulling your hair out for hours trying to figure out why on earth your network is broken. Okay, so check this out. Let's imagine a really common setup. We've got three VPCs, all set up in a chain. A is paired with B, and B is paired with C. Simple enough. Now, you look at this and you think, well, it's logical, right? A server in VPC A should be able to get to a server in VPC C. It just routes through the middle one, VPC B. Makes sense, doesn't it? Yeah, no. That is completely 100% wrong. And this is the part that drives people crazy. That traffic from A that's headed for C, it will never, ever make it. AWS just silently drops the packets inside VPC B. You don't get an error, there's no alert, it just vanishes into thin air. So what's going on here has a name. It's called non-transitive routing. It just means that because A is connected to B and B is connected to C, that does not create an automatic path between A and C. By its very design, VPC pairing is strictly non-transitive. But why? Why doesn't it just work? Here's the thing you have to get. A peering connection isn't a router. It's not a transit point. It is just a direct link between two and only two VPCs. So VPC B knows how to talk to A, and it knows how to talk to C. But it has absolutely no instructions and no permission to act like a mailman and forward traffic between them. And I am not kidding here, you guys. Misunderstanding this one single rule is the #1 most common and often the most costly mistake that architects and engineers make when they're designing their networks in the cloud using VPC peering. Okay, so now that we know the big rule you absolutely cannot break, let's talk about the blueprint. When should you actually use VPC peering? When is it the right tool for the job? This really breaks it down perfectly. VPC peering is awesome for small setups, especially anything with less than 3 VPCs. It is perfect for those simple point-to-point connections where you just need two specific things to be able to talk to each other. But on the flip side, the second your network grows beyond 3 VPCs or you start thinking about a hub-and-spoke model, peering is the wrong choice. It's also not meant for sharing a central internet gateway or anything like that. And hey, here are a few other little pitfalls to keep in your back pocket. Seriously, these are absolute favorites on certification exams and in technical interviews, so listen up. You can't peer two VPCs if their IP address ranges overlap. all. You also can't use your peer's internet gateway to get to the internet, and you can't use their NAT gateway either. Every VPC is on its own for those things. So where does that leave us? We figured out that VPC peering is a simple, pretty powerful tool, but it's got this super specific, really rigid limitation. So what happens when you outgrow it? What's the next step? Let's just circle back to this quote from the source material because it says it all. VPC peering is for simple, stable, point-to-point connections. It is not for large network topologies. If you remember one thing, remember that. So really, the bottom line is this. If your architecture is growing, if you need that hub-and-spoke model, or if you're managing more than just a handful of VPCs, you've basically hit the ceiling of what peering can do for you. You need a different tool. And that tool, the one that was literally built from the ground up to solve this exact non-transitive routing problem, is the AWS Transit Gateway. It's designed to be a true cloud router, a central hub that automatically knows how to route traffic between any and every VPC you attach to it. Which really just leaves us with one final big picture question. Your company is scaling up. You're not dealing with 2 or 3 VPCs anymore. You're looking at 10, 20, maybe even 100, spread all across the globe. You need a network that can handle all that complexity and scale with you. So, what now?